Hello students, welcome to the video on classification of power amplifiers. Depending on the position of operating point, there are different classes for the power amplifiers. Power amplifiers are mainly classified into Class A power amplifiers, Class B power amplifiers, Class C power amplifiers and Class AB power amplifiers. This classification is depending on the position of operating point. Now, coming to the Class A power amplifier. For the Class A power amplifier, if you observe, this is the load line, see here. And here, the operating point is the middle of DC load line. Okay, Q is middle of DC load line. Okay, so now as the Q is in the middle of DC load line, then see this is input you are giving. Here this is the input current. The input current is the base current. Sinusoidal base current is due to the sinusoidal signal that you applied for the circuit of Class A. Okay, so now for this input current, you're going to get two things. One is the output current IC, okay, and the other one is output voltage VCE. As the input current is in the form of sinusoidal, output current is also in the form of sinusoidal, and output voltage is also in the form of sinusoidal. But why this output voltage is in reverse? Means with the phase shift, because the Class A power amplifier is in common emitter configuration. We know for the common emitter configuration, there exists phase shift. Yes. Now if you observe, this is the input current. Okay. And for the full cycle of input current, up to this it is the full cycle. For full cycle of input current, you are getting full cycle of output current. Okay, this is output current. And full cycle of output voltage also. Okay, so you can say collector current flows for total cycle, flows for 360 degree. Okay, and now if you observe output current or output voltage, there is no loss of the signal, or you can say there is no distortion. You got the total cycle as output. You didn't miss any single part. You didn't lose any single part. That is the reason the Class A power amplifier is not having any distortion. Okay. And another point is, though it has no distortion, it is having less efficiency because of high power dissipation. Okay. Under this Class A amplifiers, yes, in future classes, we are going to see two things. One is series fed. The other one is transformer couple. Okay. Yes. The next power amplifier is Class B power amplifier. Yes, if you observe Class B power amplifier, yes, this is the position of operating point. Where is the operating point? Operating point is Q is on x-axis. Okay, as Q is on x-axis, suppose if you apply input signal like this, your Q point must coincide with the middle of your signal. So now if you apply input signal like this is the input current IB. Yes, as this negative portion is not included on the DC load line, you are not going to get output related to this negative half cycle. So that is the reason, yes, you didn't get the waveform related to the negative half cycle. We got only the waveform related to the positive half cycle. See this, if you extend it, yes, I'll get this positive half cycle of output current and the negative half cycle of output voltage. But you missed this portion. Okay, so that is the Class B. So this is the input cycle, total cycle. But for the total input cycle, we are getting only 1/2 cycle as output Okay, yes, this is output current and 1/2 cycle of the output voltage. So what is happening here is, as the negative cycle is totally missed, we got maximum amount of distortion. So to avoid this, okay, to decrease this wastage of the signal, yes, you're going to use another transistor. One transistor will conduct for 1/2 cycle, another transistor will conduct for this cycle. So what will happen? The output consists of both cycles. Okay, you're going to get this type of output. You'll get full cycle output. Okay, so that is by using another transistor. The arrangement is called class B push-pull and class B complementary symmetry. Okay, so in the class B also we are going to see two types, push-pull and complementary symmetry. Okay, so this is about class B. So definitely there exists distortion because because the entire conduction is not by only the single transistor. The conduction is by two different transistors. When the conduction is transferring from one transistor to another transistor, definitely there exists some distortion. Okay, so that distortion is called harmonic distortion. Okay, so the efficiency in the case of class B amplifier is more compared to class A. Then the next one is class C power amplifier. So if you observe class C power amplifier, the Q point is below the x-axis. Okay, Q is below x-axis. As Q is below x-axis, suppose if you apply a waveform like this, yes, now if you extend this, yes, and this is the positive half cycle. Only this part of the positive half cycle, is aligned with the DC load line. This portion is not aligned with the DC load line. Yes, this is below the x-axis. So what are you going to get? Not going to get this portion. Okay, you're going to get only this portion. Is the reason the output is not even 180. Yes, it is less than 180. This is total 180. Okay, but we are getting only this portion as output. If you see the output waveform, this is total half cycle. In that only this part is conducting. Okay, so now coming to the waveforms, this is input full cycle. But here the output collector current is this portion only, the shaded portion only. What is the angle? It is less than 180. Same way, the output waveform is for less than 180. Okay, so this is class C. So here distortion is there definitely, but the efficiency of class C power amplifier is very high. Sometimes it may reach up to 100%. Okay, so that is about class C. Now coming to class AB. Where is the operating point here? Say this. Where is the operating point here? Say this. This is the operating point. Operating point is above the x-axis and below the midpoint of DC load line. Okay. So what will happen? Suppose if you apply the waveform like this. Yes, you're going to get full half cycle and also this portion of the signal. This portion of the signal. Okay, so totally 1/2 cycle and a part of the next half cycle. Okay, so you're going to get this as output. So if you see the output waveform, see here, this is 1/2 cycle and this portion is a part of the second half cycle. Even in the output also you can observe that this is the output. Okay, so now coming to the waveforms. For the full cycle of input, the collector current flows for greater than 180 but less than 360. Even the output voltage also. Obviously in class AB also we are going to get distortion. Okay, and another important point is class AB efficiency is very near to the class B. Okay, because the shift in operating point, say this actually for class B it is on x-axis and for class AB it is above x-axis. This shift in Q point is very small. Hence, we can say the efficiency of class AB power amplifier is same as that of efficiency of class B. Now, the comparison between the power amplifiers. Yes, first take class A. The Q point is the center of load line. Therefore, collector current flows for 360. Okay, definitely no distortion. Yes, the efficiency is 4. Hence, the dissipation is very high. And this is the waveform which has full cycle output. Coming to class B, the position of the Q point is on x-axis. So the collector current flow is 180. So if you observe, the collector current flow is 180. And the efficiency is 78.5. Distortion is there. It is more than class A. So, and as the efficiency is more, the power dissipation is less. Now coming to class C, it is below x-axis, Q point is below x-axis. So the conduction angle is less than 180. So the conduction angle is, see here, see the waveform. And then efficiency is very high actually. Distortion is high, but the dissipation is very low as the efficiency is very high. Coming to class AB, the Q point is above x-axis but below the center of DC load line. So the angle of conduction or the collector current flows for greater than 180 and less than 360. See the waveform. Okay. Higher than A but less than B. So it is between 50% to 78.5%. And distortion is there. Power dissipation is moderate. Okay. So this is about the comparison between the power amplifiers. Okay. So this concludes the classification of power amplifiers. In future videos, I'll explain each and every power amplifier. Okay. Thank you very much.